Hello everybody. Well, I figured since I'm stuck in this extraordinarily slow traffic jam, why not make a video? No, it's not going to be about the traffic jam, but oh wow, there's a chunk of wood in the road. Big chunk of wood. Nice size too, I could have used that. Anyways, wrong vehicle for picking up chunks of wood on the road. Today's video is going to be about, it's a little bit of a mashup on the whole subject. Power factor correction, kilovolt ampere reduction, and those lovely power save units that seem to be for sale everywhere that claim to lower your electric bill. And how they are... If you want the juice, you need to just hold on to the juice. Put it in, you got your own cup holder. Put it in your cup holder. Nope. Oh, an accident. That would explain quite a bit. That's a little more than a minor accident. Oh, well. So anyways, power saving units called, like, one of the most famous ones are the Power Save 1200. And I actually have one that I can that I opened up, and I can show you exactly what's in it. They retail for about $3.50, and it's got about $20 worth of parts, and you can make one yourself if you so desire. Are they a scam? Yes and no. Depends where you are, what your electric utility is, and how you're billed. Most electricians that market these and sell them will not tell you the full story, because that's easy cash in their pocket. They do have the bonus side effect of surge protection, and I will test the one that I have, which I picked up relatively cheap for the sole purpose of finding out what the heck was inside. It actually did save my house from a surge when I lived in a area that had old rundown utility lines. Then lightning struck not too far away. Both houses on either side of me, pretty much everything electronic was toasted. My house was pretty much untouched. Clock radio burned up, and I think that was about it. Everything else was pretty much safe. I guess that is a minor accident. Oh, someone's getting arrested. Oh, never mind. Semi-involved. Wow, they should have been driving a Tesla. Anyways, so, power factor. First off, I'm going to forward you all to the website save-energy.org. They actually, they have a very nice write-up on power factor correction, and explains it fairly well, and I couldn't have simplified it better myself, so that's what I'm going to be referring to during this video. So I'm just trying to give them their credit where credit is due. But basically, power factor is a measure of how efficient electrical power is consumed. Ideal power factor is going to be a power factor of 1. When you see things that say, you know, XXX efficiency, common like the computer world, or even the Tesla that I'm driving, Tesla says charging on a 240 volt connection, it's 90% efficient. The charger's 90% efficient. Oh, there's dead chicken in the road. Huh, that's different. Guess that chicken didn't cross the road, but it sure got smushed on one. And ooh, gas tanker. Yeah, I guess that was a really bad accident. But Tesla says the charger in the Model S is 90% efficient, which means out of all the power going into it, 90% of that power is actually being used for what it was intended for. So it has a power factor of 0.9. Like I said, the ideal power factor is 1, not 0.9. Very few things actually do have a number one power factor. heating elements such as an electric stove, anything like that where you have a heating element is going to have a power factor of 1. A toaster, incandescent light bulb, power factor of 1. That means, or I shouldn't say 1, because you'll always have there's nothing as perfectly efficient, but it is so close. You're talking a power factor of 0.99999. I mean, it's so close. You're better off just rounding it to 1. That's how close. It's as efficient as possible can get. Why are you licking my hand, Vinny? Oh, you're funny. Now, you have other things like motors. Motors are inherently inefficient. That's why most of the motors you see will have power factor correction built into them, as well as, which is a capacitor. Capacitors are what are used generally for most power factor correction. And also, your AC powered motors need that capacitor to help generate the magnetic field to start turning. But depending on the size of the capacitor, can increase the power factor, and the idea is get it as close to 1 as possible. I have done some experimenting with capacitors. I even build capacitive battery chargers. Now, let's see. Take a little peek here. I think I'll just follow this website a little bit, and I'll just branch off of what points they're making. That extra. Okay, so like I said, power factor unity of 1 is ideal. And the extra energy that is not used or lost is known as reactive power. Like I say, with a motor, you need it's needed for the magnetizing effect required by motors and other inductive loads. Reactive power can also be interpreted as wattless, magnetizing, or also wasted power. As if you have a device that has a low power factor, all that extra power is just wasted. Usually wasted in the form of heat in your power lines, both on the utility side and in your home. Drop from the pole. So that's bad, because that means your generation facility. So right here, I'm in Milwaukee County. Most of our power is served by the Oak Creek coal plant. So that means all that wasted power, that coal plant has to generate more to be able to make up for that loss. And guess what that means? It means they're burning more coal, more pollution, and also more coal burned means more money wasted. More money wasted means your electric bill goes up. Now, there are these devices that are called Killavolt Ampere Reduction Units, or also KVARs. Are these scams, or do they work? Well, they do work. But is it going to save you money on your monthly electric bill or not? Let's touch on a few points. Almost every modern device has some sort of power factor correction. Uh-oh, what did you do? That better not be a poopies back there. So, anyways, I'll give you an example. I have a very large fan I use at my shop. Number one, it's got a very small capacitor in it. And that capacitor acts twofold. One, it acts to help provide the magnetizing effect required for that the motor to be able to spin. And two, it also increases the power factor. The lower the capacity of the capacitor, and the lower the power factor. So let's just say that that fan has with a real small or even no capacitor, just enough to get it to get moving and turning, which is pretty much all that they used to use many years ago, just enough to get it to work. Why? Save money on the construction of the equipment. Who knows else why. So we'll say it has a 0.5 power factor, or simpler terms, a 50% power factor. We'll say 100% would be 1 unity. So that means, say the fan is 50 watts. At a 0.5 power factor, we're burning 100 watts to be able to turn the fan at 50 watts. Now, the power used in the fan is still 50 watts. You're not going to change that. But that rest of that reactive power is just sent back through the lines and is wasted as heat. Now we put a little bit larger capacitor in there, and it is possible to oversize the capacitors, or the power factor correction as well. I'll touch on that in a moment. So let's say we put a slightly larger capacitor in. Now that fan has a power factor of 0.9 or 90%. That means to power that 50 watt fan, now we're only drawing 10% more instead of 50% more. So instead of drawing 100 watts to power a 50 watt fan, now we're only going to, I think my math always sucks, so feel free to correct me if I'm wrong, don't be hating, but I believe that would be 50% would be 10 watts. What are you saying, Gino? So only 10 watts worth of power is lost in the lines. Much improved. It's now another problem with low power factor is because of that wasted power, your line can't carry as much useful power. So if you have a 15 amp circuit, and I know for sustained loads you're only supposed to use 80% of a circuit, so we'll just forget about that just for simplicity. Let's say a 100 amp circuit. So now if you have, say, a 5 or a 10% power factor on that 100 amp circuit, you are only going to be able to draw about 10 amps, 5 or 10 amps, because the rest of that's all being wasted as heat. But you increase the power factor, you also increase that capacity of the line. So we bring that power factor up to 90%. So now that 90% means you could draw 90 amps on that 100 amp circuit. I know I'm not 100% accurate on this for y'all, but I'm trying to make this as simple as possible. Gino, what are you talking about? Bananas? I see you got, yes, you have lovely toesies. Thank you. Good boy. You want juice? Here you go. So, for simplicity's sake. Now, whoa, that is one crazy ass man. Did you guys see that? Just past us? Might have to rewind and pause it for a second there. Looked like a big bus with 2 Vanagons welded to the top. That's crazy. Let's see. Where was I? Now, reason number 1, those power factor correction devices are kind of a ripoff. Is, like I said, pretty much everything nowadays has power factor correction built into it already. My air compressor, just a cheap Chinese unit from Harbor Freight Tools, has 2 40 millifarad, was it microfarad? Micro. Can never keep it straight. Whatever. It's got two MF caps in it, 2 40 MF caps in it, and I measure the power factor at about. It fluctuates about 87 to 90%, so 0.87 to 0.9 power factor. Not bad. I remove 1 cap and power factor drops down significantly. But I was just giving that as an example. My fans, got it. Your furnace fan, it's got it. Your fart fan in your bathroom, get rid of the poopy smell. It's got a cap in there. Might not be a big one. You might not even think it looks like a cap. Most people think of those little silver cylinders that look like miniature soda cans as capacitors. Well, they are, but they can come in many different shapes and sizes as well. So pretty much everything's got it nowadays. I don't know enough about correcting electronic devices power factor, which is called active power factor correction. So I will not be discussing that in this video. I haven't really experimented with that, but it's corrected in a little bit different way than adding capacitors, so it's a little more complicated. I've got to do a little more research on that first. So pretty much every motor load you got nowadays has a capacitor, and also the manufacturer sizes, or at least attempts to size, the capacitor for the most efficiency, cost and fit to efficiency. So pretty much everything's sized just about right. The lowest power factor I've noticed on a device that I was just doing some playing around and measuring was about 0.7. That's pretty low. Gene, Sissity. Which is pretty low by today's standards. Now, things like your compact fluorescent light bulbs, now those usually end up with a horrible power factor. I'm usually seeing about 50% on those. The cheaper the bulb, the lower the power factor seems to be. You have those 4 bulbs for $1 at the dollar store. I've seen some of those go as low as 0.2 power factor, so they can get pretty nasty there. Wow, that lady had she's on her cell phone, no wonder. People talking on their cell phones, not watching where they're driving, which is almost every accident I ever see nowadays. So, once again, those are electronic loads, and I don't know enough about power factor correction on those to really make any decent comments. Now, so that's reason number 1 why those KVAR power factor correction units are not necessary and are somewhat of a waste of money. Number 2, you are generally a resident or small residential home or small business is not billed by a kilovolt ampere. Kilovolt ampere is the total power consumed. So, say you got a 100 watt device that's only 90% efficient, so that means it's drawing 110 watts. Or 110 watts is used to power the 100 watt device. That means you have a KVAR of 110, or kilovolt ampere of 110. You're using 100 watts, but your kilovolt ampere is 110. Most of you will notice this if you ever buy, say, a battery backup for your computer, where it will have both the watt rating and the kilovolt ampere rating. And that is, you don't ever exceed the kilovolt ampere rating. Well, you don't want to exceed the watt rating either, but kilovolt ampere rating is usually slightly higher than the watt rating because they're trying to factor in for those lower efficiencies. Now, like I said, mostly it's the industrial or factories that are billed by kilovolt ampere because of the large, insanely large equipment they have. Does draw, massive amounts of electricity as compared to what you were drawing in your home. A lot more complicated for metering for those businesses too. But and also they're getting a bit of a price break on their power usually when you're consuming that much. So they are a little more proactive on making sure that factories have lower power factor. So factories do have big units like the KVAR units all around if they are billed by power factor, or the KVAR. Now in your residence, you're billed by the watts. So technically, you could be drawing 200 amps from your house. You have a 200 amp panel, service entrance. You could have a crap power factor. It costs you absolutely nothing, but it's actually costing the power company all that extra money because you're not being billed for it. You're just being billed for the watts, the actual power, not that wasted reactive power. So, since you're not being billed for it, why spend 400, I've seen them as low as I think 250, but usually 400, 3, 4, 5, I've even seen them go for $1,000. Same unit, $20 worth of parts inside there. And it's just a waste of money. You are doing absolutely nothing. Another problem comes up that I had mentioned earlier. Generally, the power factor correction / capacitors are sized for the specific load. It is possible to oversize the power factor correction. And what happens if you do that? All right, now you just brought the power factor of your house up to its maximum, but you have those capacitors oversized. So what happens? Well, guess what? You're still connected to the grid. And because you're still connected to the grid, guess what? You're starting to correct all your neighbors' power factors. Yes, that's right. It does work like that. But now you're getting all that power coming through your meter, correcting your neighbors' power factors. Guess what that means? Now you're getting billed by your utility for that power you are taking into your home, correcting. So your bill is actually going to go up, not down. Big waste. Now, if you have a massive home, lots of motors running, a couple air conditioning units, like I say, manufacturers of air conditioning units, motors, all that, try to get their power factor as close as possible, reasonably possible, but there's always going to be a little leeway. So, if you have a massive house, lots of motors, things going like that, you might get away with not correcting your neighbor's power factor and just dealing with your own, but it's not worth it. Pretty much the only thing, so yeah, that's part number 2. Why do you want to spend more money when you're not saving anything? Now, I did mention they make great surge protectors, and that they do. All those whole house surge protectors, all they are tiny little capacitors, all different sizes. I've seen pretty much any make and model of capacitor you can imagine. Everything from thin film little semiconductor ones on up. And for the most part, those power save units, at least the one I have, has 2 40 millifarad or microfarad. Damn, I can always get those mixed up. 2 MF capacitors in there. And that's it. Since capacitors correct the power factor, that's all they did. Shove 2 capacitors in a pretty box, put a rivet in it saying don't open, and oh look, we're UL, we passed UL, or we have UL certification, Underwriter Laboratory. Big deal. That just means it's pretty much a safe product. Doesn't mean it does work, but for residents, you don't need it. Small business, you don't need it. It is oversized as a whole home surge protector. You're better off just getting one that was designed and sized as a whole home surge protector. So, 2 40 MF capacitors. Retail on those, or you can even use just a single 80, which I tried that too. Worked perfect. If you're talking about replacing what's in there, or trying to price it up. So 2 MF capacitors is about $4, maybe $5. But 24 inches of wiring. I think it was 8 AWG, if I'm remembering correctly, or 8 gauge wiring. There's another $3 or $4. The enclosure was about 10 I saw at the hardware store. And that's it. I'll at the end of this video, I will have 2 things. One, I will show the power save unit inside and outside. And another thing is utilities do their own power factor correction. And I noticed my camera's running out of battery, so I'm going to cut to the chase here. I also have a video, some clips that I'm adding to this video of a pole-mounted power factor correction device. Utilities do it right at your pole. They usually do it on the neighborhood level. That saves them a lot of money in the transmission lines. So why correct it at home when the utility's already correcting it anyways? It's not like they're really wasting anything. So there you have it. I hope I did at least a somewhat decent job of explaining this. But if you have any questions, post in the comments section and I will do my best to answer them. As most of my videos are, I just do them on the fly as I think of something. I just do a video before I forget about it. And once again, I would like to thank save-energy.org. Very good information. I would highly recommend anybody that's interested in more detailed explanations that I can't really provide over the video to visit that website, and plenty of stuff to learn about. And they have some pretty good examples of power factor, low power factor, and correction, and explain reactive power and whatnot. So that's it. I'm going to bid you all adieu and see you next video. This is the PowerSave 1200 made by PowerSave Energy Corp. I'll show you guys a close-up of the panel. Gino, don't touch that. Now there's a rivet here, so you cannot open it up, and of course do not remove cover or no serviceable parts, which is actually bullshit. And it actually even tells you may hold 2 40 MF caps. Gino? Oh, good boy. Oh, these kids driving me nuts today. So we open it up. Oh, and it has a neat little light to show you. Oh, power's on. Oh, look at that. 2 40 millifarad caps. Microfarad, millifarad, whatever. You got the idea.
Is that a shoe?
Or in other words,
Yes, a shoe.
one of these. Actually, this is a bigger capacity than what's in there.
Is that a shoe? Is that a shoe?
Okay, yeah. All right, there's a picture of my shoe. Gino? Say hi, Gene.
Is that a shoe?
No, that's wrong.
Shoe.
Yes, okay, shoe. So there you have it.
Hey.
And they do have
It's a bag.
some sort of diode on there. I believe that's a discharge. So, or a resistor. So I believe that discharges. So if it's disconnected from power, it will automatically discharge the caps. And of course, you just have the. Oops, why am I zoomed in yet? You got ground, one leg, second leg, so 240 volts. And that's it. $200 to $500-ish for a few dollar capacitor in a fancy box with a little light. What can I say? Sucker born every minute. And there's Vinny. Say hi, Vinny. Vin. There we go. Dino, say hi. Say hi. No, no gimme. And we are at the Madison Supercharger. All right, next up, next clip will be of the utility pole-mounted power factor correction, or KVAR, Killavolt Ampere Reduction Unit. This is an example of a utilities pole-mounted power factor correction, also known as Killavolt Ampere Reduction, which is basically a series of capacitors.